Hi, everyone. This is Dr. Dean Wiseman. I am your host, I guess you could say instructor for this section of Anatomy and Physiology 102 at Ivy Tech. I'm going to be seeing you during the first class, but one of my goals for this class is to, and with my other classes that I teach at Ivy Tech, is to have the equivalent lecture videos available to you should you need additional time with the material in a lecture format. So with any luck, we'll be able to generate these videos. I am doing this sort of in real time, which means that they may not all be available immediately, but we will do our best to get them out as quickly as possible. So without any further ado, let's go ahead and get started. Instead of publishing a long omnibus video of the entire lecture in one continuous video, what I have been doing recently is breaking up the videos into smaller, shorter chunks. So for this part, I'm going to call this part 1A. It'll be roughly about 30 minutes long. And then a part 1B. That's both for the material that we have for class 1. One thing I should say now, and you should probably already know this, is that whenever we reference specific things in the book, it is extremely important that you take some time and go do that. I realize that being a student in the here and now, fewer and fewer students are electing, and I say it's a choice, it is a choice, are electing to choose not to go into the reading, and I think that's a huge mistake. So if you're going to go that way, at least do us the favor and look at the ones we're looking at specifically. But I strongly urge you to read the material alongside the lecture. I know you're busy. I know you got a lot going on, but this is an accelerated course, so you really do need to have more free time to tackle it. We covered what would be normally 16 weeks of material in 8. So it's a busy schedule. But back to the digestive system. So again, with these figures and these page numbers, certainly ingestion. We have to take the food in the first place. Then we have to move it through the digestive tract down towards the outflow, if you will. The primary method of doing this is called peristalsis, and there are a couple of forms of that. We also have to make the material into something that we can actually take across a cell membrane. We call this digestion on the macro level, and there's a mechanical version of this primarily occurring in the mouth, though some peristalsis will also assist with this. That process in the mouth we call mastication, using teeth, tongue, and mouth muscles. But we also have stomach churn, and even peristalsis can play a role, segmentation. All right, the segmental peristalsis is a form of mechanical breakdown. Then we have chemical digestion. This involves enzymes, also involves stomach acid. Primarily the pancreas is the number one secretor of digestive enzymes. And we call these specialized digestive enzymes, sometimes we call them zymogens. I get a little nervous, with so many words talking about the same thing. They're freaking digestive enzymes. Why don't we just leave it at that, right? At least have some awareness of that word. We are going to be secreting fluid. It's actually the tune of 8 liters, which is a huge amount considering that you only have 5 liters of blood. That's pretty impressive. And we have to get across the cell membranes. Okay, so our primary absorptive surface is going to be the small intestine. What we're doing is we're making the molecules small enough, but we're also breaking them down into their basic monomers. For instance, proteins broken down into amino acids. Carbohydrates broken down into simple sugars, small transportable molecules. Cell membrane doesn't allow many things through. It's regulated absorption and transport, diffusion, and one of the primary drivers is size. And then lastly, any material that we do not absorb or this is good, or that we actually introduce into the digestive tract. Sometimes we secrete things. All right, we do get rid of material from the body through the digestive tract. It's called the biliary route. And so defecation, This is the removal of an unabsorbed and or secreted material into the digestive tract. It is a major source of getting rid of drugs. It's a major source of getting rid of bilirubin, which is the metabolic byproduct of hemoglobin. So we shouldn't dismiss this as just simply undigested or unabsorbed food. Sometimes we call the digestive tract the alimentary tract or the alimentary canal. So obviously the mouth, teeth, tongue, esophagus, stomach, small intestine. There are three segments of the small intestine. All right, duodenum, ileum, and jejunum. Large intestine, there are also three parts there. And then we also have the rectum and the anus, which are actually separate. People don't realize there are actually two sections there. Then we have accessory organs, salivary glands in and around the mouth, the liver, the gallbladder storing bile, and lastly, the pancreas. As always, this is an anatomy course in addition to being physiology, so it is important that you understand the three-dimensional position of these things. And so we have the digestive tract organ list here on the right with the arrows corresponding to their approximate locations. Then on the left, we have the accessory organs, salivary glands, liver, gallbladder, and pancreas. So make sure that not only do you understand basic function, but for purposes of lab and lab exam, you're going to want to be able to identify these things visually in a three-dimensional context. Some other terms for you: when we swallow food or fluid or or beverage, we mix it with saliva, even the liquid parts, and when we swallow it, it is called a bolus. All right. Once we get to the stomach, though, it's no longer a bolus because it's mixing with gastric secretions, previously swallowed food, etc. When we mix in the stomach and then down through the small intestine, we call that material chyme. Now, when chyme comes up out of the stomach, we call that vomit. All right. And then we have feces, which is the material after we've absorbed things from the chyme, as well as introduced new material. For instance, like I said, the biliary route, that is bile, not only is meant in a digestive purpose, it's also meant in a secretion and excretion purpose. So the feces is material that's remaining, but also material that's been secreted through the bile that is meant to be removed from the body. And remember that the large intestine is not merely an absorptive surface, it's primarily a desiccating surface. That is to say, it is mostly transporting water. So the longer it resides in the small intestine, or the large intestine, the more water is absorbed, and that leads to things like constipation and fecal impaction. And some anatomical terms to know: hard palate, that's the top of your mouth, the surface, the bone with a little bit of epithelium over top of it. The soft palate, you got to understand that that's where where snoring arises. So if people have snoring issues, that's and or sometimes sleep apnea is exacerbated by the soft palate here. We have the oropharynx, we have the nasopharynx, we have the laryngopharynx. It's all this sort of common space here in this area above and around the epiglottis. Then we have tonsils, which are not shown here. Tonsils are actually lymph nodes, or a specialized lymph node. They're part of the immune system. And then we have the uvula, which is often featured in cartoons. When you see somebody yelling really loud, they show that there. We'll talk about that in the upcoming slides. Obviously, we should know the tongue. That's a pretty good one. All right. And underneath the tongue, you have this ligament called the frenulum. All right. Very painful to injure that, by the way. Got teeth. We're going to talk about the different kinds of teeth. We certainly have the mouth muscles, masseter, and that sort of a thing that are involved in this mechanical digestion and laceration of food. We are doing a physical reduction in the size of the particles. This is the first step, along with mixing with saliva in order to facilitate diffusion. You should Try to chew your food. Not You don't have to chew excessively. There is a point where things get a little bit out of hand, and there have been some debates about this. But you should chew your food for a good 20 seconds. If you take a decent amount of food, you should chew it for that period of time. You can sing the happy birthday song, but I wouldn't want to sing happy birthday every time I took a bite. But you want to get a good seven or eight chews on your food before you swallow it. That really does facilitate digestion and gastrointestinal health. Tongue is also not only involved in the emulsification and processing of food, but it's certainly important in speech, certainly important in swallowing as well. And you might recall from Anatomy and Physiology 101, we talked about the different types of taste buds and where they were located. But here, this picture is really about the tonsils, which are specialized lymph nodes. They are for immune surveillance. They are there to monitor the exposure to potential pathogens and to mediate immune responses where appropriate. Many of you will be doing routine oral and throat exams. So a healthy throat, you can see here's the uvula here, and here are two of the tonsils. When they are swollen up, they are pronounced. And in some cases, especially in young children, can be potentially life-threatening because they are now beginning to occlude the ability to inhale and inspire air. That's one of the dangers with croup and whooping cough is inflammation in this particular part of the upper airway. Again, just some additional images of the same things we've already been talking about with an emphasis on uvula function. It's just a structure that hangs off. It's right there at the back of the soft palate there. And what it's doing is it's actually working with the epiglottis to prevent fluids in food going into the nasopharynx or into the nasal cavity when you swallow. If you've ever had that happen accidentally, like if you laugh while you have food and so forth, it's a quite an unpleasant experience depending on the kind of food that you have. And if you're like me and you like hot sauce and spicy, it can be almost painful. So never pleasant, and the uvula is important. It's sort of like a reverse epiglottis for the nasal passages, whereas the epiglottis is protecting the trachea. A little bit about teeth, since they're super important for general digestive health and function. We start off with what we call baby teeth, and the reason being is that the jawline is so compacted at this point. Things that don't change in a person's life, certainly their brain size does not change significantly. Your eyes don't change significantly. You have the same size eyes that you were born with. They do not grow. But your jaw, in particular, your nose and your ears will grow over an entire lifetime. So if you look at an older person, you'll see that the cartilage in the nose has continued to grow, and they tend to have larger noses than most of the population. Same thing with ears as well. But the jawline grows up until about the age, into young adulthood. And so what happens is you start off with a smaller set of teeth that you then replace with a larger number and larger size teeth. So we have baby teeth, and that includes some incisors, central and lateral. We have what are called canine teeth, which are cuspids. They are more round, more pointed, and then we have flat grinders, molars, and that's the same is true on the bottom as well. You've got four incisors, a couple of canines, and then four molars. Then in the adult, what we have is 32. So we still have same number of incisors. We also have the canines, but now we've got these premolars and we've added a set of molars. Sometimes these last set of molars, these third molars, we call them wisdom teeth. Sometimes those have to be extracted because the jaw doesn't grow as much as we would like. or the teeth can be large relative to the jaw. Teeth size and jaw size do matter in these things. And so you have a total of 32 teeth. It's fairly symmetrical. I'm not too worried about the formula so much. When it comes to individual teeth structure, we have three regions. You have the upper area, the crown. This is what we're most used to seeing. We have the neck, which is at or below the gingiva, which is the gingival margin, which is the gums, and then finally down into the bony area of the jaw we call the root. And then there are five terms. Certainly, we have to know the gingiva, which is again the gums, the central tube of the root called the root canal. You have two of them. The pulp is a kind of a soft, fleshy epithelial material, sometimes a little bit of connective tissue, but primarily epithelium. And then you have harder extracellular matrix in terms of dentin, and then the ceramic enamel on the apical surface. There are three different salivary glands. We have the parotid, which is sort of up and underneath your ear. You have underneath the tongue, but apical. That's called the sublingual, and then the submandibular. These are both controlled by cranial nerve 7, whereas parotid is cranial nerve 9. When you introduce saliva to the bolus of food that you're chewing on, you're not only breaking down the large molecules with your teeth and your tongue, you're lubricating the material, but you are also introducing enzymes. Now, enzymes are proteins. That's what most enzymes are. Sometimes they have a little more than just protein, but in any case, these things are metabolizing molecules. What they're doing is they're taking a large molecule that they can target and chopping up the chemical bonds in order to make smaller molecules. And generally run under an ideal, pH and a temperature. In your mouth, that pH will be relatively high, temperature will be relatively low. So we have what's called salivary amylase. And what salivary amylase does is it will break down a starch molecule into smaller sugar-like molecules. If you've ever been really, really hungry and you go to your favorite Mexican restaurant, you sit down and then they hand you those tortillas chips with the salsa, and you take that first chip and man, it tastes awesome. But then you've been eating for a while and you're pretty full and you're like, well, I'll just have one more tortilla chip, and you taste that tortilla chip and it doesn't taste as good. That's because there's less salivary amylase in your saliva breaking that starch down. And starch tastes like cardboard. It's actually quite closely related to a molecule known as cellulose, which is what cardboard is made of. But when we break those molecules down into smaller sugar-like molecules, that's where the real flavor comes from. And that's one of the benefits of cooking, is that you're breaking down some of these large molecules into smaller molecules, which is what enhances flavor. So the big enzyme in saliva is amylase. It's breaking down carbohydrates, large carbohydrate molecules, into smaller ones. There are some other enzymes, but that's the big one we'll use as an example for this class. What is the number one producer of digestive enzymes? Well, that's further down in the digestive tract. That would be the pancreas, specifically what we call the exocrine pancreas. We have exocrine and endocrine. Endocrine makes the hormones like insulin and glucagon and so forth, but the exocrine pancreas makes all of a big chunk of the digestive enzymes that our food sees as it passes through, particularly the small intestine. And speaking of the small intestine, we have the general structure here. It is a complex histological setup. It's complicated because it's doing a number of things. First of all, it's doing transport of the food through the digestive tract. It's certainly doing absorption, but it's also doing immune surveillance. All right. And we could even argue excretion, removal of materials. There are sort of 5 regions that we want to be familiar with. We certainly have the lumen, that's the central lumen. This is also known as the apical surface. So we have a basolateral surface on the outside. The inner surface that's facing the lumen is called an apical surface. Then you have the mucosa. All right, this is the mucous membrane, secretes mucus among other things, digestive enzymes. It's also where we're going to see a lot of the absorption going on. Then we have the submucosa. Loose connective tissue contains the vasculature, but also a specialized set of lymphatic vessels we call lacteals, which are important for fat absorption. Then you've got smooth muscle, a couple layers, sometimes three, and that's called the muscularis. And then you have the outermost tunic, if you will, of connective tissue, peritoneal tissue. We call that the serosa. The innermost, shall we say, apical surface of the small intestine is called the mucosa layer. This is what's coming in direct contact with things that you're bringing into the body. Certainly, absorption is really important, but secretion as well. Mucus, digestive enzymes, and some hormones. Immune surveillance is actually the largest immune tissue in the body. They have all these things called Peyer's patches and other types of immune surveillance because you're coming in direct contact with the external environment. That includes dirt, that includes things that are accidentally ingested or brought in through things like putting your fingers in your mouth, all right, and that sort of accidental contact with pathogens and so forth. The mouth is actually one of the primary ways, mouth and eyes are two of the primary ways that we introduce pathogens into our body via our fingers specifically. Then we have three sublayers of this mucosa. We certainly have the epithelia, the stratified squamous. This is a protective epithelia. It's meant to slough off in order to prevent damage to the organ. You know, it's a protective epithelium. And then we have this absorptive epithelium that we call it's a simple columnar that is involved in exchange of material with the bolus and the chyme that you've created. Then you have this lamina propria. It's basically the basal lamina of the epithelium that's lining that comprises the mucosa. All epithelia have a basal lamina, and this just happens to be the basal lamina for the mucosal layer. It's connective tissue. It's got blood vessels, and it's got those lacteals I was mentioning in the previous slide. Then below that we have the mucosa, the muscularis mucosa. It's a thin layer of smooth muscle, again designed to try to create motion and increase the effectiveness of the surface area there. And this is kind of a cool looking slide. It's showing you the esophageal sphincter here. So we have the end of the esophagus here and the beginning of the stomach, and you can see it's a profound epithelial shift. We have stratified squamous here. Again, that's a protective epithelium. And then we have columnar, which is involved in exchange. And so below the mucosal layer, we have the submucosa. This is mostly connective tissue. We have blood vessels, nerves, those lacteals, and some secretory glands in here, secreting mucus, sometimes secreting other material, bicarbonate and other things. It's also elastic. It allows for stretch and return to original shape following stretch. If you've ever had gas or if you've had indigestion, often that discomfort you're feeling is excessive stretch occurring in your digestive tract. You can't localize it because the nerves in there are branched, and so you get a lot of referred pain in those situations. And you can see here, this image, you can see there's the submucosa. It's a type of connective tissue that's underneath the apical surface, the mucosal layer. Then we have the muscularis, the externa. So we have an interna and an externa. This externa has both circular and longitudinal, so we can reduce the radius, but we can also reduce the length. And so there's a combination, if you will. Stomach contains three because you have an additional third layer that's oblique, that's going in an angular direction. This also includes the sphincters as well. So the sphincters that link, like say for the esophagus to the stomach, or the stomach, the pyloric valve, or the small intestine, large intestine, or to the rectum and anus. The outermost layer is known as the serosal layer. It's basically connective tissue that interfaces with the mesenteries. Because you have organ motion, whether it's the motion of the organs themselves or the jostling of the organs, like when you're running or walking or engaged in activity and so forth, you need to have a slippery surface or these tissues will become inflamed. A lot of people don't realize this, but one of the long-term complications of anorexia nervosa is loss of serosal lubrication. That the fat we often look at in a relatively poor dim view, but fat serves actually life conferring ability to cushion and lubricate these organs, and the serosal layer is part of that. So it's reducing friction. And anywhere you see, motion, if you look at the synovial joints or, in your fingers and your arms and so forth, or the pericardium around the heart or the pleural membrane around the lungs, these things have slippery, watery surfaces that are for lubrication. And so the serosal layer is part of the peritoneal complex of connective tissue membranes. And I have a picture here. It's just showing the stomach in this case, and you have the innermost layer, the mucosa, followed by the submucosa, then you have the muscularis, and then finally that outer surface, the serosa. If you see, like for instance, if someone's field dressing a deer or removing intestines and that sort of a thing, when you're looking at the intestine, you're actually looking at the serosal layer. And here are the four layers shown again. Again, we have that internal mucosa, epithelia. There's a lamina there, basal lamina. Then you have the muscularis mucosa. You don't mistake that for the muscularis layer. So there's actually a very thin layer of smooth muscle right in the mucosal layer. Then you have submucosa. Then you have the muscularis, if you will, the circular and the longitudinal. Or if you're in the stomach, you have a third oblique. And then fourth, you have the serosal layer, the outer connective and epithelial surface. So the membranes of the digestive tract have to kind of strike a balance between stability and support and the ability to move. I sort of equate it to like a marionette. A marionette, you have those strings that not only provide support, but also provide the ability for motion to occur. And that's sort of what's going on. And so we have different subdivisions of these membranes. Certainly, we have the outer membrane, the peritoneal membrane that aligns the inner surface of the body wall. You have the mesentery proper. This is what you would see if you were manipulating, if you were doing a dissection or something of a cat or a frog or something, and you see that sort of lacy-like membrane. That's what we call the mesentery proper. Then you have, in mammals particular, you have these fatty curtains, if you will. You have the greater one, and that's what you feel in your belly fat. That's your belly fat. And then you have a lesser one, which is a little further and up more in. When I was talking about anorexia nervosa, this is the one that if you lose this, you begin to have real problems with literally loss of integrity of the organs because they're rubbing against each other too much. So the greater omentum is the one that you feel when you press against your belly. Lesser one is inside, and this is the one that gets lost during anorexia nervosa. The last one is what's called the mesocolon. Mesocolon is just again a membrane that is sort of supporting the large intestine. All right, it's a longer ligament curtain that is really tasked with colonic support. Here's a picture of the greater omentum. Again, that's what you feel when you feel belly fat. Lesser omentum would be up in here in between the organs. A little bit about the esophagus. It's a really interesting organ. It's a muscular tube that conveys the food bolus down to the stomach. And it has a mix of skeletal and smooth muscle. The first third or so is entirely
skeletal muscle, and we even have this thing called we call the upper esophageal sphincter. For that reason, most people are aware of this the sphincter there at the entrance of the stomach, but no, not many people realize there's one up here as well, and that's mostly skeletal muscle. In the middle third of the esophagus, you have a mix of skeletal and smooth muscle, and then finally the bottom third is entirely smooth muscle. And like I said, it's carrying the bolus of food from the mouth, the oral cavity, to the stomach. It is a protective epithelium because there is a lot of friction here, interaction between the wall of the esophagus that's pushing this material. And so you're sloughing off cells continually, just like your skin, only it's a mucous membrane that secretes lubricant. We also have the epiglottis here. We would be remiss for not talking about that. Most people are familiar with the epiglottis because if you get either liquid or particles past it into the trachea, then you can choke, or if you don't choke, you certainly aspirate, and that can lead to inflammation and lung damage from the material that's entering that trachea and then the lungs. So so we have the uvula on the top side, and we have the epiglottis on the bottom. Most of us do have some intrinsic sense of peristalsis. We've probably heard about it in the past. The thing I would tell you about the esophagus is that it sort of gives us a misrepresentation of what peristalsis actually is. Because the the esophagus is relatively short. It's shorter by a third or more than the other parts of the digestive tract. It really can't do the sort of longitudinal shortening that we see in the other parts of the digestive system that are much more representative of true peristalsis. In the esophageal peristalsis, it's primarily circular, that you get a constriction, if you will, and that wave of constriction is what propels the bolus, probably with a little bit of a gravity assist as well, down the esophagus. And that's not an unusual reason for why you want to be in a relatively upright position while you're eating. It makes the movement of that bolus into the stomach much more efficient. If you're lying sideways, or you can do it, in unusual positions, it's just not as efficient. One of the products of peristalsis, especially we're talking about intestinal peristalsis, so gastric may be involved as well, is a word called borborygmi, which is the plural form of borborygmus. Borborygmi is the gurgling, or occasionally it sounds like rumbling, and it can vary in intensity and frequency depending on what you've consumed, but it's the sound made by peristalsis. As peristalsis happens in the intestines, and it can happen also in the stomach, you have movement of gas. Mostly that's air. Sometimes it's other things. It could be methane or carbon dioxide in some cases, because you do have bacteria that populate your intestinal tract, and they often will generate carbon dioxide and methane. In any case, though, that peristalsis leads to the bubbling of gas as it moves through your intestines, and that's what's called borborygmi. So if you have somebody you trust that you're very close to, young children, people who are interested in learning, you can do this with a stethoscope. It's possible to do that, but the best way to do it, to listen to borborygmi, is to actually put your ear directly on the belly of somebody else. It doesn't have to be on the skin per se. It could be through a t-shirt or something like that. But this is one of these few times, well, I won't say few, but one of these times where you can really make physiology fun. Rather than it being something that you're kind of slogging through, you can actually use your understanding of physiology for entertainment, or for educational fun things if you're working with young kids. So have at it. Make physiology as fun as possible. Another issue with using the esophagus as a representative of peristalsis, we talked about a couple of slides earlier, is that we tend to think that peristalsis is solely for movement, and it's not. We call the process, the peristaltic process of segmentation, is actually to mix and churn, what we would call emulsification, in addition to the movement. So this could be literally part of the mechanical digestion process. When you are emulsifying and churning, what you're doing is you're allowing a mixture of fluids and solids, as well as increasing the potential contact of enzymes with the materials that they will interact with and break down. This concludes the section, what we call Part 1A. I will commence now into the individual structures of the digestive tract, starting in Part 1B. So thank you for your time, and I will see you again soon.